Welcome to the course of drone surveying. In this course, today we are starting the first lecture, which is on Introduction to Land Surveying. So, what do you learn in this lecture? You will learn what is land surveying, what is the purpose, why do we carry out the land surveying, what are the various applications of the land surveying, what are the very classification of land surveying, and what type of measurements we are taking in surveying, and all about the topographical mapping, which is very popular in land surveying topic. So, when we talk about the land surveying, it is the foundation of any infrastructure project. It is the primary requirement to have an updated map of the land so that our planning is perfect. So, if we define what is land surveying, in surveying is basically the technique of acquiring the position of the objects on the earth surface, and what type of measurements we are taking. We are taking the distance, we are taking angular measurements, we are taking the elevation measurement. So, with the help of these measurements, we are trying to locate the object on a piece of paper, and we draw the maps according to the purpose of the map. There could be various objectives of land surveying, but the primary objective of land surveying is that we determine three-dimensional coordinates. It is x, y, z of the ground points. But in real world coordinates, we call it latitude, longitude, and the elevation of the point. So, once we know these three-dimensional coordinates, we can draw them in the form of a map. We can find out the distance between the points, we can find out the area of the polygon, we can find out the elevation difference. The second objective could be we prepare various types of maps for different purpose. Maybe we like to map the boundary of the state, boundary of the land. We want to prepare the maps of the buildings, road, railways, pipelines, rivers, canal, bridges, etc., etc. And another objective is, once we prepare the map, then we will like to carry out the measurements on them. It could be measuring the distance between the 2 points, measuring the area of a polygon, or maybe calculating the volume of the earthwork, etc. So, if we define the map, it is a graphical representation of the earth surface showing natural and cultural features. So, all the natural and cultural features what we see on the ground, we represent them graphically in the form of point feature, line feature, and area feature at some defined scale. And these ground features are shown with the different symbols and colors. We do not show normally the actual size, but we show them by their standard symbols and the colors. And at the end, we give a legend so that anybody can read these maps. Map will show how features and objects are related to each other in terms of the direction, in terms of the coordinates, in terms of the distance and size. So, there could be a different type of maps. You must have heard about the topographical maps, which are very popular in civil engineering, but there are other kind of maps also, like word map, physical map, and so on. When we prepare the map, we normally select the scale of the map, which is very important, because all the features, if we are not showing them by the actual size and shape, then we have to show them symbolically. So, the map scale is very important. We define the map scale into three parts: the mesoscale map, which is shown on the top here, and the local scale map, which will cover a small region as compared to the mesoscale. When we want to cover a big township, we will go for the mesoscale. But micro scale map, which is given at the bottom, is the largest scale map which we prepare to cover a small area, but with very detailed kind of information. Because our accuracy of mapping is also related to the scale. So, it is very important whenever we survey an area, when we try to map the area, we have to decide at what scale we are going to map the features. Why land mapping? Why do we carry out the land mapping? Why it is so important? We know that population is growing, resources are limited, land is limited on the earth for different uses to sustain the population, to meet the demand of the population. So land become very costly commodity, so its accurate mapping is very, very important. We must know the land in our possession, the land which is available next to us. As the population is growing, there is a tremendous pressure, as we know, on the land surface for its various utilization, maybe for housing purpose, maybe for other amenities which are coming, maybe for agriculture use. So its accurate location, its shape and its size, they are all needed. So on the, when we prepare the map, we show all these three so that we understand the location, we understand what is the shape of the land piece and what are the different sizes, and its optimum utilization is required for sustainable planning. So there are very large number of uses why this land mapping is required. Most of the land records, as we know in India, are mapped on papers. So all our earlier maps, they are available on paper using conventional methods, maybe the chain surveying, maybe the compass surveying that was used to prepare those maps. Then later on, vernier theodolites were used for measuring the angles. So all these equipment have their inherent characteristics. So the maps which are prepared by using those conventional equipment, they are prone to some kind of error. They are not as accurate as today we are preparing by digital methods. So today we are shifting from 2D maps to the 3D maps so that we can have visualization of the whole terrain right sitting in the office, and if the paper is shrinking or expanding, it will, due to the climatic condition, it will affect our 2D paper maps. But when we have 3D digital maps, they are much more, they give much more accurate visualization of the land surface, and planning becomes much more perfect. So what we need? We need accurate maps showing the location of the hills, valley, river, villages, town, forest, roads, rivers, etc. We like to show the exact boundary of the fields, the location of the houses and other properties and amenities. And most importantly, the accurate engineering map showing the details like road, railway, canal, contours, etc. are needed for better planning, and we call them engineering maps or the topographical maps. There are large number of engineering applications of surveying. That is what we prepare the maps. We have to plan, we have to construct, maintain highway, railroad, building, bridges, tunnels, canal, dam, water supply and sewerage systems, pipeline, etc. That is why these maps are required. We have to guide the erection of the large equipment such as airplanes and ship. Computation of drainage area, catchment area, volume of the earthwork. For this purpose, we require maps. We also require maps for monitoring purpose. If we have the maps at regular interval, we can monitor many of the natural disaster like landslides, dam deformation or the settlements, etc. in any given area. So there are, we can see that there are very large number of engineering applications of the surveying. Basically, it involves three important steps. Step 1. Step 1 is the observations. We are taking observations using various kind of equipment. So today we have very large number of equipment we will discuss in subsequent lecture. So what we do when we are taking the observation? We compute the distance between the points, we determine the angles, horizontal angle as well as the vertical angles. We determine the direction of the object with respect to the reference, which is the north direction. We calculate the elevations of various points with respect to a datum, and normally we call it a mean sea level, but nowadays we are using WGS 84 datum when we carry out GPS related activities. Then we also measure the coordinates because coordinates are very important today when we are preparing the map, 2D map or 3D maps, and when we are doing the subsequent computations from there. So there are various kinds of equipment which are used, as you can see here in the figure. Total station is being used on my right side. The digital level is being used for taking the observations. So we must know how to take the observations from them. The next step is mapping on a piece of paper, which was earlier done. So most popular technique earlier was preparing the map on a piece of paper using plane table methods. In plane table methods, we have to carry in the field lot of equipment, we have to take the observations, and we have to draw the map on a piece of paper after taking the observations toward the different objects. So we were preparing these maps at different scales, and updation of the map was also difficult because every time you have to go to the field to update the details which are changing on the ground. Then step 3 was the measurements. Once you have prepared the maps, then they were used actually to take certain measurements from the map, so that these measurements can be used for better planning, for accurate planning of the facilities on the ground. So these measurements include length, area, determining the perimeter, determining the elevation and elevation difference of the points, and determining the coordinates. So these are all 3 important steps which are involved in the mapping system. Then if we look at the classification of the surveying, basically in the primary classification we have 2 categories. Broad categories are plane surveying and geodetic surveying. So these are the 2 broad categories for which we are preparing the maps. In plane surveying, what we do is, as the name suggests, the shape of the earth, we know that it is spherical and the earth surface is curved, it is undulating. But in plane surveying, what we do is, because the area covered is small, so we neglect the curvature of the earth. We do not take the curvature of the earth into our computation, in our corrections, and we consider, because the area is small, we consider that the earth surface is a plane or is a flat. So we do not take into account the shape of the earth in this direction. So as we can see here, the triangle between the 3 points, so joined by a straight line, but actually on the ground this may be curved if the area is large. So degree of accuracy which we actually get from this type of surveying is not as high as in geodetic surveying, but we take care that there should not be much error while we are taking the observations. Normally, if our area which we are surveying is less than 250 kilometers square, we call it a plane surveying method. So normally for topographical mapping, for engineering mapping, we go for the plane surveying most of the time. But geodetic surveying is also popular. When our area becomes large, then we have to consider the topography of the earth surface, curved surface into account, because the line joining any 2 points is considered as the curved line, as is shown in the figure on the top. Again, 3 points have been joined, but these are not joined by a straight line, because the curvature of the earth has been taken into account here. The area covered is much larger. For example, if we have to carry out the mapping for the entire state, that comes under the geodetic surveying, and we have to establish few control points with very high precision or accuracy in order to carry out the entire mapping. So we are using very sophisticated equipment, very precise equipment. This will give us very high accuracy at the end. There are other classification of the surveying which are given in the literature, and these classification vary with respect to the instrument used, as you can see in the first column. According to the instrument which are used, the classification have been made. So earlier we were using chain and tapes, then levels for taking the elevation, theodolite and tachymeter, magnetic compass for direction, plane table for preparing the paper based maps. Then in the digital era, we started using EDM, electronic distance measuring device, total station, digital level, GPS, smart station, ground penetrating radar, laser level and LiDAR system. So according to the instrument use, the classification of surveying has been made. The second classification is based on the method which is given in the middle column here. If we are doing leveling elevation difference between the 2 points, this is called the leveling methods. We may doing traversing when we have various points around the object and it's a closed traverse or it may be open traverse. Similarly, we have triangulation and triliteration. If the area covered is large, we are using actually all these different methods. Now, the third column shows the purpose of the surveying. So, there could be many purposes. As I told you, we are preparing different kind of maps for different purpose. So, whether our purpose is to prepare the engineering maps, topographical maps, or we are doing geodetic mapping, or we are simply preparing the maps for route survey, whether it is a route for the road or rail or maybe a canal systems, or we are doing the mine survey, geological survey, underground utility mapping. So, depending upon the purpose, hydrographic survey for example is a altogether different concepts from the land surveying. So, depending upon the purpose, the classification of the surveying has been done. Now, surveying measurements are done to understand the ground. We understand the undulations in the ground, we understand what are the different features which are present in the ground, we understand the extent, the limit of the ground. We understand if there is any obstruction when we carry out the survey of the ground. And we plot all the natural and cultural features which are present in the area depending upon the importance of the project, depending upon the requirement of the project. Then we prepare a map required for planning and execution of the work. We determine various things from the maps as already been told: length, angles, height, coordinates, area, volume. All these features can be easily computed from these maps. Now, if we have to determine the distance between the 2 points, that measurement is called the linear measurement, and linear measurement is the basis of all surveying, because without measuring the distance between the 2 points, it is difficult to show the location on the map. It is required to know the slope distance. With the help of the linear distance, we can find out the horizontal distance between the 2 points. We need angle in order to determine the slope distance. So, all these measurements are required to determine the shape of the area, shape of the field in which mapping is carried out. It is also required to compute the area of the field once we carry out. It is if it is a rectangular field, it is very easy calculations once we know the length and the breadth of the. So, we are using conventionally the tapes for measuring the shorter distance, but the tapes, measuring tapes have their own limitations. They give error if the distance measured between a 2 point is long. Then measurements of angles and directions. So, our old maps, they are based on the measurement of distance and measurement of directions. So, angles, as we know, we are measuring nowadays with the theodolites or using the total station. And we are measuring two types of angles here, horizontal angle and vertical angle. The one in the diagram here on the top is shown as a vernier theodolite. It is nowadays obsolete and it has been replaced by total station. Now, coming to the direction, we are measuring the direction with the help of the magnetic compass, and we are all finding out the horizontal angle between the object and the reference meridian, which is our north line. So, the direction also is very important in civil engineering projects when we commission the projects, and these directions could be all these compass direction: north, northeast, east, southeast, south, southwest, west and northwest, and compasses are used. Nowadays we have digital compass, we have many apps which we can download and can find out the direction using those apps. Measurement of elevations. We are measuring the elevations of different points with the help of instrument which we call the levels. But with the passage of time, with the development of the technology, we have automatic levels, we have laser levels, we have total station, or we have the GPS, which we are used nowadays for the leveling work. The one in the right in the diagram is the auto level. So, we are using along with a staff which is shown over here, we take the reading on the staff. For example, the small h is the reading, we know the height of the instrument level which is kept at point A. So, we from these two readings we can find out what is the elevation difference between A and B, and once we know the elevation of a point which is known as the benchmark, we can find out the elevation of unknown point which is B. So, this was the leveling procedure measuring the elevation of the different points, because we need to know the slope of the ground at the end. So, here we are using several terms, and some of the terms maybe you are aware of. Datum, for example, it is any level surface to which we are measuring the elevations. Elevations are referenced with respect to this datum in the vertical direction. Then another term is the mean sea level, which is the average height of the surface of the sea for all these stages of the tide over a 19-year period. This mean sea level is a local datum. Then third important term is the benchmark. It is relatively a permanent mark whose elevation from the datum is known. If, for example, in India, the benchmark have been established by Survey of India, Dehradun. So, elevation of these points are already known, and to determine the elevation of the other point, we should know the elevation of one point. Then determination of the coordinates. So, earlier the determination of the coordinates all were done manually. Once we have taken the observation, here d is the distance, theta actually is the direction with respect to the north. So, we can do, northing will be d cos theta and easting will be d sin theta. So, this is all manual calculation. We were determining the latitude and departure of the various lines, and if it is a close traverse, we were adjusting them, applying the corrections. But nowadays, we can determine these coordinates very easily with the help of the modern devices. So, once we have determined these coordinates, the objects were plotted on a piece of paper at a defined scale, and many software now are available. Once we know three-dimensional coordinates, we can prepare two-dimensional map or three-dimensional maps. We can show the terrain in the third dimension. So, topographical maps were prepared at large scale, which are widely used almost in all engineering projects. So, these coordinates were very important. So, earlier we were determining the coordinates from the measurements which we were taking, but nowadays what we are doing is we are directly determining the coordinates from many of the instruments. Now, earlier maps were based on distance and direction, as I already told you, and these are comparatively less precise because of the least count of the equipment or the methods which were used. Distance was measured with chain or tape, and direction mostly with the magnetic compass, and these maps were all manually prepared with lots of computation which are also done manually. But today the modern maps require three-dimensional coordinates, which we can get from the LiDAR surveying, which we can get from the GPS also, three-dimensional coordinates of the various object, and these are considered to be more precise than the previous equipment. These modern equipment directly give us three-dimensional coordinates, and we can prepare the maps using the capabilities of the software. So, the process has become much faster and it is much more accurate. Now, if you look at the future of surveying, what is the future of surveying? These are some of the advances in the future. We will completely replace all those old methods with the GNSS or GPS, which has been introduced almost in all surveying equipment, and the advantage of this is that we directly get the three-dimensional coordinates, which is the basic requirement to prepare a map or create a three-dimensional model, or if we have to carry out analysis in the GIS environment, then directly we can use this data. we require large scale maps, and today large scale aerial photography we can do from the drone survey, which you will learn in subsequent lectures. So today we have the technology of drone survey where we can have large scale aerial photographs and at a frequency as and when we require it. We have very high resolution remote sensing images also, through which we can prepare a large scale map. We have the LiDAR point cloud data for 3D mapping. Earlier 3D mapping was a very difficult task, but today with the availability of the point cloud data, the LiDAR data LiDAR sensor which we can mount on the drone, we can collect this data and create a 3D mapping. So this is the basically in future we are going to use all this technology when we are talking of land survey or preparing the maps for different purpose. So there are some suggested readings for you further, and thank you very much for listening the lecture.